The green square represents a bird's eye view of the walls of the barn without a roof. Since the problem doesn't specify whether the goat is tied to a corner inside or outside of the barn, we'll have to consider both cases separately. Let's assume that all of the barn doors are closed to keep things as simple as possible. First, let's assume that the goat is tied to a corner on the inside of the barn. It doesn't matter which one, so let's say the upper left corner. The longest distance inside of the barn is from one diagonal corner to another. We can find that distance using the Pythagorean theorem, but using a shortcut from geometry would be quicker. A line from one diagonal corner in the barn to another cuts the barn into two congruent isosceles right, or 45-45-90 triangles. In this kind of triangle, the base angles will always have the same length, and the hypotenuse will always be the square root of 2 times the length of a base. So if the base or a side of the barn measures 100 feet, the diagonal will measure square root of 2 times 100 feet, or about 1.414 times 100 feet, which is 141.4 feet. Since the rope that the goat is tied to is 200 feet long, that means that the goat can roam around every square foot of the barn, which has an area of 100 feet times 100 feet, or 10,000 square feet. Now, let's assume that the goat is tied to a corner on the outside of the barn. Again, it doesn't matter which one, the result will be the same no matter which one it is. Let's tie the goat at the upper left corner again. If the goat walks straight in any possible direction, it can roam a maximum of 200 feet from its starting point. Since the rope can't pass through the walls of the barn, keeping the rope taut, the goat can sweep an area that is 3/4 of a circle with a radius of 200 feet. If the goat decided to do something different and roam first along a wall of the barn, then turn the corner and walk to the next corner, keeping the rope taut, it would be able to roam an extra quarter circle whose radius is 100 feet from the diagonally opposite corner to the edge of the 3/4 circle, and the goat can do that in two ways. The area of a circle is pi times the radius squared, so the area of the 3/4 circle is approximately 0.75 times 3.14 times 200 square feet, which is 0.75 times 3.14 times 40,000 square feet, or 94,200 square feet. The area of the 2/4 circles, which combined is the area of a half circle with a radius of 100 feet, is approximately 0.5 times 3.14 times 10,000 square feet, or 15,700 square feet. The approximate total area that the goat can roam outside of the barn is 94,200 square feet plus 15,700 square feet, or 109,900 square feet. If a door is open, then the goat would be able to roam both inside and outside of the barn. Exactly how much space the goat would be able to cover then depends on the placement of the door relative to the corner that the goat is tied to.